Here we go. It's your lucky day. We get to solve equations now with decimals and fractions. But before we begin, we do have a disclaimer. That's correct. Solving equations with decimals and fractions are done exactly the same way as solving equations with integers. That's right, folks. You will still use the distributive property. You will still combine like terms if needed. And you will still do order of operations backwards to get the variable alone, which means you always get rid of adding and subtracting, then multiplying and dividing, then your exponents, and lastly parentheses because order of operation goes backwards when you're solving equations. So, really, the only difference we're doing today is we're playing with these equations. And yes, I mean play because this is so much fun. We're doing this with decimals or fractions, but not together. So, we'll get started. Our first equation with decimals is 0.07x equals 22 minus 0.025x. Just ignore the fact that there's decimals. What do you notice about the x's? They're on two sides of the equal sign. So first thing you have to do is group them up. Now, because this side only has an x and no other number, and the right side has a 22 and a take away 0.25x, I would move this one over to here. Why? Because then my x's would be together, so I'm going to add 0.25, and then I'd have a number all by itself when I'm done. Because negative 0.25 plus 0.25 is 0, so that cancels out, and 0.07 plus 0.25 is 0.32x equals 22. All right, now I've got 0.32 times x, and the opposite of multiplying is divide both sides by 0.32. 0.32 divided by 0.32 is 1x. Ta-da! Just what we wanted. And now, of course, please use your calculator. And do 22 divided by 0.32, and when you hit the equal sign, you will be like, x equals 68.75. All right, so the steps were exactly the same. It just happens to have a decimal. Well, let's make it a little bit harder. They can't all be this easy, right? Okay. What do you notice here? Come on, you've done lots of these problems. When you have a number next to parentheses, what does that mean? We have $500 for the answer. Do you have the correct answer? Yes, that means you need to use the distributive property. First thing we have to do is give everybody in the parentheses that 0.75 by multiplication. So 0.75 times 3, 0.75 times negative 4. And that gives you 2.25n, take away 3, and we did nothing to the right side except copy it down. Okay, we have n's on the left and n's on the right. Step 2 means get those n's together. Get your variables on the same side. Do you want to move your 225? Do you want to move your 5.5? It doesn't matter. I'm going to go with subtract 5.5 from both sides. Just a preference. You can do it either way. You'll get the same answer. Trust me. So 2.25n, take away 5.5n. If you don't feel comfortable doing that in your head because 2.25 is smaller than this, do it on your calculator. But 5.5n, take away 5.5n is 0. So we're just left with the 10 on the right side. And so we have negative 3.25n, take away 3 equals 10. It's starting to look fun. I have a multiplying and subtraction. Order of operation backwards says get rid of subtraction. And the opposite of subtracting 3 is add. That's right. Add 3 to both sides. So we'll add 3 to the left, add 3 to the right. And what will we get? Negative 3.25n equals 13. So negative 3.25 times n. So how do we get n alone? The opposite of multiplying by 3.25, or negative 3.25, is divide. Divide both sides by negative 3.25. And guess what? A negative 3.25 divided by a negative 3.25 is a positive 1n, which means you have isolated your variable. You've been very successful. And with your handy-dandy calculator, you type in 13 divided by negative 3.25, and you'll get a negative answer because a positive divided by a negative is a negative. And it went evenly, negative 4. Yeah, it was so anticlimactic. After all of this mess, the answer is negative 4. So that's it with decimals. You can do it. Just follow the same steps, grab your calculator. It's with fractions that things get a little different. I know everybody has their fractional feelings, but I'm going to show you two methods. Method 1 is you're going to keep the fractions as fractions and solve them. And when the problems are little, I'm going to call this a little problem, meaning there's just one fraction and a couple of regular numbers, Just keep the fraction. Trust me. Okay, so I have a k, a take away 12, and a 60. So the k is over here, so I need to move my take away 12. So I'm going to add 12 to both sides. So that leaves me my 8/9 k equals 72. This is 8/9 times k. And the opposite of multiplying by 8/9 is to divide. But we've learned, when we studied fractions back on lesson 3, we learned that dividing by fractions is the same as multiplying by the reciprocal. And the reciprocal of 8/9, as you flip it over, it's 9/8. So we're not going to divide, because dividing is nothing more, when you're dealing with fractions, than multiplying by the reciprocal. So I'm going to multiply the left by 9/8 and multiply the right by 9/8, because 9 cancels with 9 because they're diagonal from each other. And the 8 will cancel with 8. Basically, they're not canceling, they're dividing, they're equaling 1. So that means I've got 1 times 1 and 1 times 1, so I'm left with 1k. Score! That's what I wanted anyway. To multiply on this side, 72 times 9/8, you might get a little stressed, but 72 times 9/8 is really the fraction 72 over 1 times 9/8. Let me just put it over to the side. 72 over 1 times 9/8. Now I could multiply straight across, but I'm going to get a huge number. So I like to do something called cross reduce the 72 and the 8. Why? Because they have something in common. What's their GCF? 8. Say 8. That's right, 8. So I'm going to take 72, divide it by 8, and I get 9. And then diagonally across, 8 divided by 8 is 1. Now I'm going to multiply straight across. 9 times 9 is 81. 1 times 1 is 1. And 81 divided by 1 is 81. So when it's an easier fraction problem, keep your fraction. I'll show you what happens when you have more than one fraction and you try to keep your fractions. Okay, so we notice that I have a variable here, an h on the left and an h on the right. So the first step is to get them together and not fight, fight, fight. I felt like I was rhyming there, for a moment, so I thought I might have to. Anyway, so let's go ahead and move our half of an h over here. It's just half an h. It was being added. The opposite of adding half an h, subtract. So we're going to subtract half an h. But do you notice the problem right away? We don't have the same denominator. Oh no, not the same denominator. Yeah, oh no is correct. In order to subtract the fractions, you have to have a common denominator. And 3 and 2, the least common denominator, is going to be 6. So 2/3 would equal 4/6, so we'll have 4/6h. And 1/2 is 3/6, so 2 times 3, 1 times 3. And now I can go ahead and subtract, because I have 4/6 take away 3/6, which is 1/6. So I'm left with 1/6h plus 3 equals -6. Okay, so that was the tricky part, moving a fraction over. You had to get a common denominator. You can't ignore fraction rules. Fraction rules are fraction rules forever and ever and ever. But this doesn't look bad. Okay, we got multiplying and adding. Order of operations backward to get rid of the adding. So I'm going to subtract 3. Subtract 3. -6 take away 3 is -9. I have 1/6h equals -9. The opposite of multiplying by 1/6h, remember it's fraction. We're going to multiply by the reciprocal. And the reciprocal of 1/6 is 6 over 1. And look at the 6's diagonally. 6 divided by 6 is 1. 1 divided by 1 is 1. There they go. So we're left with 1h. And over here we multiply straight across, -9 times 6. And remember the denominator for 9 is 1. So we end up with -54. Okay, so that's not too bad when you keep the fractions. Actually, that wasn't pretty. But I'm going to show you the exact same problem. See, same numbers. You already know the answer. See, the answer is -54. Same exact problem, but we're going to do it with a method number 2, clearing the fractions. Okay, he showed it to you in the video, Brother Bear did. The first step will be to clear the fractions. So what is the least common multiple of the two fractions? Of 3 and 2. Remember, it was 6. We're going to multiply every term by 6. So let's make sure you understand what that means. I multiply 2/3 h by 6. I multiply this 3 here by 6. Cross your equal sign. And -6 by 6. My 1/2 h by 6. See, I put all my 6's in red. You have to multiply every single term by 6. Because what happens is this is going to get rid of your denominator because it cross cancels. 6 divided by 3 is 2. So 2 times 2 is 4h, plus 6 times 3 is 18, equals 6 times negative 6 is negative 36. And now here we go. 6 and 2 cross cancel. 2 goes into 6 3 times. 3 times 1 is 3. Yeah, you no longer have a fraction problem. This method is way awesome. Way awesome. If you multiply every single term, you can't skip anything. I mean, even the regular numbers were multiplied by 6. Because now we're going, oh, dude, I totally see I've got my h's I can group up. I'm going to move my 3h over, so I'm going to subtract it. 4h minus 3h gives me 1h. Okay, I've got plus 18. I need to move it, so I'm going to subtract my 18 over. And guess what negative 36 minus 18 is? Negative 54. Yeah, like a rock star. Let me tell ya, it was pretty awesome. Let's do it again. Okay. Oh, whoa. Look at this. 2/3 x plus 5/3 2x minus 4 equals 9/8 x plus 7/6. I'd like to tell you to clear the fractions first. So let's try that. I've got a 3, an 8, and a 6. Yeah, 24. Yeah, that's your least common multiple. 8 and 6 go to 24. 3 and 3 go to 24. We multiply everybody by 24. Because the 24 and the 3 cross cancel, and that becomes 8 times 2, which is 16x. Excuse me. Again, it's 23 and 4, or 23 and 4. How about 24 and 3? They're going to cross reduce, and I'm going to get 8 times 5, which is 40. You don't have to do this parentheses because this is the distributive property, so you leave this alone. Cross your equal sign. Now I have 24 and the 8. They're going to cross reduce. And 24 divided by 8 is 3. So 3 times 9 is 27. And then last 24 over here. 24 and 6, when you cross reduce, it's going to be 6 goes into 24 4 times. And 4 times 7 is 28. So let's use that distributive property. Multiply by 40. So moving through there, 40 times 2, 40 times 4. Combine like terms here. 16x plus 80x gives you 96x. Now that we've cleaned up the left, let's start moving things over. I've got my positive 27x, so I subtract it from both sides. 96x take away 27x gives us 69x. I'm left with just a 28 on the right. So to get my 69x, take away 160. I'm going to have to add 160 to both sides. 69x equals 188, and the opposite of multiplying by 69 is divide by 69. And you end up with a really awful looking fraction, 188 over 69, and you can leave it as an improper fraction. It doesn't reduce anymore. This is an even number, an odd number. Not a lot of things go into 69 except 3. 8 plus 8 is 16. That's equals 17, so 3 doesn't go into 188. I did go through this part rather quickly, just because they're the same steps we've been using over and over again. The trick was up here, line 2. All right, you want to try it one more time. What? What in the world is this? Yeah, these are complex fractions. So the numerator is x minus 4. That whole thing is the numerator. And the denominator is 3. On the other side of the equal sign, the whole numerator is 2x plus 5. The denominator is 9. So step 1, what's the least common multiple of 3 and 9? 9. Say 9. That's right, 9. That's right. So we're going to multiply every term by 9. What that means is this whole fraction is one term. And this is one fraction, so it is also one term. So 3 goes into 9 3 times. So I'm left with 3 times my numerator. 9 goes into 9 one time, so I'm left with 2x plus 5. Okay. Yeah, you may want to pause the video and process that, huh? Now I just use my distributive property, 3x times, 3 times x and 3 times negative 4. Now we're going to combine like terms. I feel like moving my 2x over, so I'll end up with subtracting 2x. So I have 1x minus 12 equals 5. What's next? Move the 12. Add 12 to both sides, so x equals 17. Yeah, that was pretty cool, wasn't it? I know. Whoa! Yeah, you're doing cool stuff now. I like it. Okay, so go ahead and write this one down. You pause the video, come back, we'll walk through it. Just give it a shot on your own. Or we'll go through the first steps together and then you can give it a shot on your own. Okay, welcome back. Did you figure out what to do? All right, our first part is this is a complex fraction. It's got a Expression for a numerator and 14 for the denominator. 6 is not a fraction, but the x has 3 sevens. So we're looking for the least common multiple of 14 and 7, and the least common multiple is 14. So we need to multiply every term. Now remember, this is one complex fraction, so I only multiply x plus 7 over 14 by 14. The 6 is one term, so I multiply it by 14. The 3 sevenths x is one term, so I multiply it by 14. All right, so over here, I've got my 14 cancels with my 14, or it reduces to 1, so I'm left with x plus 7. 14 times 6, 84. And then the 7 and the 14 cross-reduce, so the 7 divided by 7 is 1, and 14 divided by 7 is 2. 2 times 3 is 6. What do you want to do next? Yeah, let's add. I like adding. Let's add that 6x over. So we'll add 6x over because 1x plus 6x is 7x. We're going to subtract 7 because we know how to do these next steps pretty quick. 84 minus 7 is 77. So 7 times what is 77? Divide both sides by 7 and you get 11. X equals 11. Yay! Okay. Yeah, you've been doing tough work, so congratulations. This is not easy. You may want to watch this again. Maybe mute me, but you can do it. You can always email me if you have questions. Hope you have a great day.